Good morning dear students, welcome back. I am your physics professor Dr. Nagaraj. So with this video I am going to start with the discussion of model question paper. This is paper number 1. You people were asking for the discussion of model paper, so I thought it is appropriate and relevant at when examinations are at the corner. Well, I as usual go ahead with the detailed explanation of each and every question. I will divide the whole question paper into 5 parts. Each part will be covering one module. As you all know, there are totally 5 modules in physics syllabus. Accordingly, I will divide the paper into 5 parts. Dear students, first I would like to tell you one thing. The most common problem and complaint about physics paper is that it is very lengthy. Many students feel that paper is very lengthy. So whenever I ask my students after the examination, they used to give this comment. Sir, paper was easy, but it was lengthy. I could not find the sufficient time to answer all the questions. Yes, I do agree with this. In physics, there are not only derivation type questions, even descriptive type questions also. So you have to answer in detail. But what to do? For all the subjects, time duration is 3 hours only. You have to manage the time, learn how to manage the time. Practice the derivations before you go to the examination, and answers you can write either in paragraph wise or in bullet wise, but it should convey the meaning. Overall meaning must be there. Okay, so time management is very important. Physics, of course, there are numericals also. Each module there will be one numerical. You will have to answer one numerical. That means totally, well, I will explain the question paper pattern. There are 10 questions or 10 numericals are there. On an average, you will have 5 or 4 marks. So totally 5 5s of 25. 20 to 25 marks numericals will be there. So there you can save time. Okay. So anyway, please try to manage the time and practice the answers before you go to the class. Before you go to the examination. VTU has released one model paper. Very shortly they may release another one more or 2 more papers. We are also waiting, and as and when they release the paper, I will try to solve those question papers. Meanwhile, I will share some important questions or probable questions or selected questions from each chapter practice. Okay, so dear students, come with this brief introduction. I move on to the general instructions. As you all know, there will be 3 hour duration and totally 100 marks, and you have to answer 5 full questions out of 10, and that means each module will be having 2 questions. You will have to answer at least one, choosing from each module. Okay, 5 modules means 5 2s are 10 questions, 1 question from each module. And general instructions also includes some general instructions like draw neat sketches wherever it is necessary. Okay, so that means you have to draw the neat diagrams, and physical constants will be given like speed of light, Boltzmann constant, Planck's constant, acceleration due to gravity, mass of the electron. Of course, mass is not mentioned here, but it will be there in the question paper. Permittivity, permeability, whatever is required for solving the numerical, those constants will be there. You need not have to remember all these physical constants. Okay, and like this the question paper looks, and there will be, as I told just now, there will be totally 5 modules. Module 1, module 2, and then module 3, module 4, module 5, and in each module you will have 2 questions. Question number 1, question number 2, and among 1 and 2 there will be choice. This is called internal choice, and then 3 and 4 again there is internal choice. Similarly, between 4 and 5 and 6, 7 and 8, 9 and 10. Okay, so question number 1 and 2 will be module 1, that is laser and optical fiber. Question number 3 and 4 will be from modern physics or quantum mechanics. 5 and 6 will be from quantum computation. 7 and 8 will be on electrical conductivity and superconductivity. Module 5, that is 9 and 10, will be on physics of animation and statistical physics. Okay, see, look at the question paper. Constants are provided, general instructions are provided, formula handbook is permitted. This is the added advantage. First time they have introduced this. So that means they will be providing formula handbook in the examination. Okay, most likely they will provide, because it is given in instruction. Look at the instruction number 2. VTU formula handbook is permitted. Okay, so they will give the formula handbook. Okay, anyway, Now coming to questions pattern, there will be three columns. One is marks column, next one is Bloom's taxonomy level, and course outcome CO1, CO2, CO3. Dear students, you need not have to bother about this L and C, that is second column and third column. Look at only the first column, that is marks allotted. Marks allotted will be totally, each question is for 20 marks. So each question will be subdivided into A, B, C, maximum D, but in this question paper I don't find any fourth subdivision. So there will be only 3 divisions. I told you, maximum of 4. Very rarely they go to fourth subdivision. So usually first 2 questions will be descriptive type and derivation type. And the last one, that is part C, will be numerical. Numerical problem is either for 4 marks or 5 marks, not more than that. Anyway, totally it will be 20. 8 plus 8, 16 plus 4, 20, or 9 plus 6, 15 plus 5, 20. So andre pratiyondu question kuda, each question is for 20 marks. That 20 marks is divided into 8, 8, 4, or 5, 5, 10, 5, 5, or 9, 6, 5, like that. Okay, this is a marks division. And whenever you have 8 marks or 9 marks question, definitely it will be more about towards derivation type. Okay, anyway, with this brief introduction, today in this video I start with the first module questions discussion. So there are totally 2 questions, question number 1 and question number 2. So I will take up this particular module discussion now in this video. Well, this is module 1. As I told, module 1 is all about laser and optical fiber. Dear students, after I finish all this module paper, complete discussion of this model paper, I will share the PDF of question and answer in the description box. Once I finish 5th module, I will share all the answers along with the questions. I hope it will help you. Okay, same procedure I follow even for the remaining model papers, if at all VTU upload in the website. Okay, I hope you will be there with me in this journey and give constant support as usual. And I am very much thankful to you for your favorite and favorable feedbacks and positive feedbacks. Okay, first module, first question comes here. Obtain the expression for energy density using Einstein's A and B coefficients, and thus conclude on B12 is equal to B21. Dear students, this is about Einstein's theory of laser. This is also called as Einstein's A and B coefficient theory. Question need not be like this. It can be directly also discuss Einstein's theory of A and B coefficients. Athava obtain the expression for energy density using Einstein's coefficients theory. Ella kuda ondene. Finally, conclusion, we have to prove that B12 is equal to B21. So this is in laser chapter. So answer, first you have to explain the interaction of radiation with matter. So you start like this. Consider 2 energy states of an atom, say E1 and E2. E1 is in the ground state, E2 will be the excited state. Therefore, E2 is greater than E1. Let N1 be the number of atoms in the E1 and N2 be the number of atoms in E2 states. When light of certain frequency nu and energy U nu is incident on it, 3 possible interactions will take place. When light falls on the ground state, atoms may absorb, atoms may jump, atoms may undergo spontaneous emission or stimulated emission. Totally 3 possibilities are there. This is what your teacher already told you. So what are those 3 possibilities? You have to give the detailed explanation because this is for 8 marks. Sometimes it will appear even for 10 marks also. In my opinion, 8 marks is less for this question. They should ask at least for 10 marks. Okay. Anyway, induced absorption takes place. First thing I told you, there are 3 possibilities. Modalanedagi, induced absorption will take place. What is induced absorption? Atoms in E1 state absorb incident photon and excite to E2 state astene. So illi ಒಂದು photon ಬಂದು ಇಲ್ಲಿ ಬೀಳುತ್ತೆ, then atom will go to excited state. This is called absorption. And this absorption is that is called rate of absorption is proportional to number of atoms in the ground state and incident energy density. ಅಂದ್ರೆ ಜಾಸ್ತಿ atoms ಇದ್ರೆ more absorption will be there. ಜೊತೆಗೆ if the energy is more, there will be more absorption. So the rate of absorption depends on number of atoms as well as incident energy. Therefore I have written rate of induced absorption is proportional to N1 U gamma or U nu. Proportionality, when you remove, then it becomes equals. Now comes one proportionality constant, that is B12 into N1 U gamma, that is nothing but equation number 1. So like this you have to write 3 different possibilities. Second possibility comes here, it is called spontaneous emission. Atoms in E2 state have certain probability to spontaneously drop to E1 level. See, you need not have to use the same words here. Main thing is what is spontaneous emission anta helbeku. Illi atom excited state ge hoyitu melike, but it won't stay there. It will come back within 10 power minus 8 seconds spontaneously. So it goes to higher level, comes down to ground state spontaneously. This is nothing but spontaneous emission. For spontaneous emission, extra energy not required. Therefore, the rate of spontaneous emission does not depend upon the incident energy. It only depends upon how many atoms are there in the excited state. So that you have to mention. So spontaneous emission does not depend on the energy. It depends only on the number of atoms in the E2 level. Nodi ee sentence anna martibidi, neeve own ag bariri. When atom is excited, it will return to the ground state within 10 power minus 8 second. This is called spontaneous emission. This does not depend on the incident energy, but depends only on the number of atoms in the excited level. So this type of ability you have to develop. Framing the answer without altering the meaning is very important. Okay, so this I have written in the form of equation. Rate of spontaneous emission is proportional to N2, that is equal to A21 N2. So I take another constant, this is A. So these two are called Einstein's A and B coefficients. B is for absorption, A is for emission. So this is B is from 1 to 2 because atom is going from ground level to higher level. A is 2 to 1 because atom is coming from second level to ground level. 1 to 2 hodre constant is 1 to, suffix is 1 to. From top to bottom it is coming, I take it as 2 to 1. Okay, I have second equation with me. Now comes the third one. Third one is stimulated emission. This is the third possibility. This is a speciality of Einstein's theory. Actually, we should be grateful to Einstein for this particular concept. Spontaneous emission anybody can expect, but stimulated emission is such a wonderful concept he introduced in 1917, and that made that change, and with the help of this concept only people started thinking about lasing action, and finally they came out with laser. In fact, one of the a very important discovery of 20th century. If you list top 10 discoveries of the 20th century, laser will be there, maybe in the first place or in the second place, not more beyond third place. Anyway, forget about the history. Coming back to this, stimulated emission andre eno? Incident photon induces the atoms in E2 level to go to E1 level. That means atoms are already in the excited level. They are about to come to ground level, that is called spontaneous emission. Before they come, the incident light will induce, will stimulate, will disturb, will influence. ಎಲ್ಲ ಒಂದೇನೆ. ಆಟಮ್ಸ್ ಅಲ್ಲಿ ಕೂತಿರ್ತಾವಲ್ಲ, ಹೋಗ್ಬಿಟ್ಟು ಆ ಆಟಮ್ಸ್ ಅನ್ನ ಡಿಸ್ಟರ್ಬ್ ಮಾಡೋದು. ಇಟ್ ವಿಲ್ ಡಿಸ್ಟರ್ಬ್ ದಿ ಆಟಮ್ಸ್, ಸೊ ಆಟಮ್ಸ್ ವಿಲ್ ಕಮ್ ಡೌನ್ ಟು ground state. This is called instigation. This is called stimulation. Okay, because of stimulation the atom will come down, one photon is emitted. Incident photon will also come without any change in the energy. That is the speciality. In spontaneous emission what happens? One photon is absorbed, atom will go up, will come down, one photon is emitted. So one photon you lose, one photon you gain. There is no loss, there is no gain. But in stimulated emission it is not so. You send one photon, one atom will come down, so atom's photon and your incident photon both will come together. Thereby the number of photons increases. So stimulated emission is therefore responsible for lasing action. After all, what is laser? Laser is nothing but multiplication of photons, production of photons, identical photons you have to get in a large number. ಹೆಚ್ಚು photons ಅನ್ನು ಪಡೆಯೋದೇನೆ lasing action. ಆ ಥರ lasing action ಬರಬೇಕು ಅಂತಂದ್ರೆ there must be stimulated emission, and this stimulated emission is proportional to N2, that is number of atoms in the excited state, also depends on the energy. So I forgot to mention U gamma here. It also depends on the energy. Energy ಜಾಸ್ತಿ ಇದ್ರೆ ಇನ್ನೂ ಜಾಸ್ತಿ stimulated emissions ಆಗುತ್ತೆ. So rate of stimulated emission depends upon N2 U gamma. Dear students, please include U gamma. I will include it in my notes. That is equal to B21 N2 U gamma. So here comes another coefficient, another proportionality constant B. B is emission, stimulated emission, that is by 2 to 1. So what is the difference between A and B, sir? A is also emission coefficient, B is also emission coefficient. A is spontaneous coefficient, B is stimulated coefficient. Okay. So you have to write these three equations. This is very important. For this itself you have 4 marks, 4 to 5 marks. Rate of absorption B12 N1 U gamma. Rate of spontaneous emission A21 N2. Rate of stimulated emission B21 N2 U gamma. That means incident light. Okay, incident rate. That means absorption rate. Okay, then spontaneous emission rate, and then stimulated emission rate. Absorption, emission. So there are three possibilities. One is absorption. Absorption will take atoms to the higher level, and then emission from higher level to lower level. There are two possible emission. One is spontaneous emission, another one is stimulated emission. So this is three interactions. This itself you can expect for 6 marks. Explain the interaction of radiation with matter. Bari ishtanna matra bariri. You need not have to go further with the derivation. If the question is like that, discuss the interaction of radiation with matter. Suppose if the question is like this, obtain the expression for energy density anta idre, then you proceed further. So I have given the meaning of A, B and B12 and B21. B12 stands for absorption coefficient, A21 stands for spontaneous emission coefficient, B21 stands for stimulated emission coefficient. Dear students, I am taking little bit more time because my intention is not only to just read the statements, my intention is also to make you to understand the statements. It is something like teaching laser. Okay, so indirectly I am teaching laser. I hope it is going to help you a lot. Right, so don't think that the video is becoming lengthy. Yes, I agree it is becoming lengthy, that's why I am reducing the duration. I will not make the full video, right? If possible I will stop after one question also. So your satisfaction is my satisfaction. Okay, your satisfaction is my requirement. Okay, now let us proceed with the derivation. Nodi, 3 ಕಂಡೀಷನ್ಸ್ ಅನ್ನು ಹೇಳಿದೆ. ಅಬ್ಸಾರ್ಪ್ಷನ್ ಆಗುತ್ತೆ, ಸ್ಪಾಂಟೇನಿಯಸ್ ಎಮಿಷನ್ ಆಗುತ್ತೆ, ಸ್ಟಿಮ್ಯುಲೇಟೆಡ್ ಎಮಿಷನ್ ಆಗುತ್ತೆ ಅಂತ. ಇನ್ ಥರ್ಮಲ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಬ್ಸಾರ್ಪ್ಷನ್ ಈಸ್ ಈಕ್ವಲ್ ಟು spontaneous emission plus stimulated emission. So how much is absorbed? That will be equal to 2 emissions. One is spontaneous emission, another one is stimulated emission. So this equation you have to write. Rate of induced absorption is equal to rate of spontaneous emission plus rate of stimulated emission. Okay, now let us substitute the equations. That is equation number 1 is equal to 2 plus 3. See the previous slide I recall. See, this is equation 1. That is rate of absorption is equal to spontaneous emission, that is A21 N2 plus stimulated emission, that is B21 N2 U gamma. That is what I have written here. Okay, so B12 N1 U gamma is equal to A21 N2 plus B21 N2 U gamma. Okay, now let us proceed further. Rearrange the terms. I take U gammas one side, so this term transfer here, and then this remain as it is. I hope the mathematical operations are self-explanatory, you can make out. Next, what you do, take U gamma common factor. you left with B12 N1 minus B21 N2, that is equal to A21 N2. So this is one stage. Now I write for U gamma is equal to, I sometimes call it as gamma, I sometimes call it as nu, please don't get confused, both will be same in this context even though there is a small difference between gamma and nu. Okay, that U gamma is equal to A21 N2 divided by this whole thing will come to denominator. This is a very simple mathematical operations. I hope you can make out. Next step, what I will do, I retain numerator as it is. In the denominator, I take B12 and then B21 and N2. The second term I take fully outside. Second term I take fully outside. So then what happens? First term will be B12 N1 by B21 N2. Okay. So second term anna nanu common ತಗೊಂಡಿದ್ದೀನಿ. Common ತಗೊಂಡಾಗ ಏನಾಗುತ್ತೆ? So ನೋಡಿ ಇಲ್ಲಿ ಈ ಟರ್ಮ್ ಪೂರ್ತಿ ಹೊರಗಡೆ ಬಂದಾಗ, so ಇಲ್ಲಿ there is no B21 N2, so therefore it will be B21 N2 minus 1 as it is. Okay, minus 1 as it is, right? Next, A21 by B21, please verify the steps. This N2 and N2 cancel. Okay, so this N2 and N2 when I cancel, then A21 B21, A21 by B21 remains as it is, right? And then in this place, that is the numerator, it is 1 divided by B12 N1 B21 N2 minus 1. This is equation number 4. Okay, so I have one equation for U gamma, but according to Boltzmann we have a substitution. N1 by N2 is equal to e to the power of h nu by kt. Therefore in this equation this term remains as it is, 1 remains as it is, B12 B21 remains as it is, N1 by N2. So in the place of N1 by N2, so this term, this whole term, okay, is replaced by e to the power of h nu by kt. Therefore I have e to the power of h nu by kt minus 1 here. Well, this is quite important equation because this is very much similar to Planck's radiation formula. Planck's radiation formula is in this form. See, this is Planck's radiation formula. U gamma is equal to 8 pi h nu cube by c cube into so much, where h is Planck's constant, nu is the frequency of incident radiation, c is the speed of light. Nodi, equation 5 and 6 they are same. LHS u nu. So RHS must be same. So if you go ahead like this, then you can write A21 by B21, adeno ide, that we need not have to worry because we have to focus only on B12 and B21. So in the place of B12 and B21, but e to the power of h nu by kt, e to the power of h nu by kt. In place of B12 and B21, there is nothing. That means here there is only number 1. So here it is 1. E jagadalli, okay, yenide, it is just 1. Therefore this equation I have. And now cross multiply, I get B12 is equal to B21. This was my question. Conclude that B12 is equal to B21. Got it? So that's all about this particular question. This is very important question. Now comes next question. Describe attenuation and explain various fiber losses. This is about optical fiber. Optical fibers alli loss is very important point. We have to give more importance and we have to take very much care about the loss factors. Energy undergo loss. Light propagates through the optical fiber. During the propagation, intensity of light reduces. Sometimes the light may be absorbed by various things present inside the optical fiber. As a result, there will be loss of energy. This is nothing but attenuation. So here comes the definition. The loss of power suffered by the optical signal as it propagates through the fiber is called attenuation. Helinala, loss of power as it propagates. Light propagate agbekadre energy loss agutte. Energy per unit time is nothing but power. So power loss agutte. So yake loss agutte annodana aamele nodona. As the light propagates, as the electromagnetic radiation propagates, there will be loss of energy. This is known as attenuation, also called as fiber loss. ಇಷ್ಟು ಬರೆದ್ರೆ ಸಾಕು. ಬಟ್ ಕೆಲವೊಮ್ಮೆ ಈಕ್ವೇಶನ್ ಅನ್ನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತಾರೆ, ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ತಾರೆ see alpha, that is called attenuation coefficient, it is equal to minus 10 by L log of output power divided by input power, and it is expressed in decibel per kilometer. So P in is power coupled into fiber, that is input power. P out is power output. L is length of the optical fiber. ಎಷ್ಟು ಉದ್ದ ಫೈಬರ್ ಅನ್ನು ತಗೊಂಡಿದ್ದೀರಾ. ಈ ಎಂಟ್ರಿ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ವಾಟ್ ಈಸ್ ದ ಪವರ್, ದಟ್ ಈಸ್ ಪವರ್ ಇನ್. ಎಕ್ಸಿಟ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಪವರ್ ಔಟ್, ದಟ್ ಈಸ್ ಔಟ್ಪುಟ್ ಪವರ್. ಅಂಡ್ ಆಲ್ವೇಸ್ ಔಟ್ಪುಟ್ ಪವರ್ ಈಸ್ ಲೆಸ್ than ಇನ್ಪುಟ್ ಪವರ್. ಓಕೆ, ವೆಲ್ ವಾಟ್ ಆರ್ ದ ಮೇನ್ ರೀಸನ್ಸ್ ಫಾರ್ ದ ಪವರ್ ಲಾಸ್? There are many reasons, but we mainly identify four reasons. Four main reasons are like this. Just write one or two lines about each power loss. Okay, because question allotted, marks allotted is 8. Dear students, that is also very important. ಆನ್ಸರ್ ಬರೆಯೋ ಮುಂಚೆ ಎಷ್ಟು ಮಾರ್ಕ್ಸ್ ಅಲಾಟ್ ಆಗಿದೆ, ಏನಾಗುತ್ತೆ ನಮಗೆ ಕ್ವಶನ್ ಅನ್ನು ನಾವು ಕರೆಕ್ಟಾಗಿ ಓದ್ಕೊಳ್ಳೋದಿಲ್ಲ. ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ಅನದರ್ ಮೇಜರ್ ಪ್ರಾಬ್ಲಮ್, ವೈ ಯು ಲೂಸ್ ಟೈಮ್. ಸೊ ವಿತೌಟ್ ರೀಡಿಂಗ್ ದಿ ಕ್ವಶನ್ ವಿ ಸ್ಟಾರ್ಟ್ ಆನ್ಸರಿಂಗ್ ವಾಟ್ ಎವರ್ ವಿ ನೋ, ಯು ಕೀಪ್ ಆನ್ ರೈಟಿಂಗ್ ಅಂಡ್ ದೇರ್ ಬೈ ವಿ ಲೂಸ್ ಟೈಮ್. ಓಕೆ, ಐ ಹವ್ ಸೀನ್ ಮೆನಿ ಸ್ಟೂಡೆಂಟ್ಸ್ ಈವನ್ ಇನ್ ದ ಇಂಟರ್ನಲ್ ಟೆಸ್ಟ್ ಆಲ್ಸೋ. ನಿಮ್ಮ ಇಂಟರ್ನಲ್ ಟೆಸ್ಟ್ ಅಲ್ಲಿ ನಾವು ಕೇಳಿರೋ ಕ್ವಶನ್ನೇ ಒಂದಿರುತ್ತೆ, ನೀವು ಬರ್ದಿರೋ ಆನ್ಸರೇ ಬೇರೆ ತರ ಇರುತ್ತೆ. ಅಂಡ್ ವಾಟ್ ಆನ್ಸರ್ ಯು ರೈಟ್ ಈಸ್ ನಾಟ್ ದಟ್ ಮಚ್ ರಿಕ್ವೈರ್ಡ್ ಫಾರ್ ದ ಕ್ವಶನ್. ಓಕೆ, ಸೊ therefore my suggestion, read the question, look at the marks allotted and then write accordingly. Suppose marks allotted is very less, ಈಗ ನೋಡಿ ಇದಕ್ಕೆ 8 marks ಇದೆ. 8 marks ಅಂದ್ರೆ definition itself will take 2 marks, remaining 6 marks. 6 marks ಗೆ ನೀವು 4 losses ಅನ್ನು explain ಮಾಡಬೇಕು ಅಂದ್ರೆ how much you have to write, right? Suppose if you write one paragraph for each loss, right, it will take more than 10 minutes and that is not required for 6 marks. You need to write maximum of 2 lines. What is that loss? What might be the reason for that? Ashtene. You need not have to explain how actually loss occur, how to avoid that loss, where this loss is more, where this loss is less, and which more this loss is more prominent. ಅವೆಲ್ಲ ಕತೆ ಹೇಳೋ ನೆಸೆಸಿಟಿ ಇಲ್ಲ. ನೋಡಿ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ absorption loss. Absorption loss means what? This loss is either due to molecules in the core material, that is called intrinsic loss, or absorption of energy by impurities such as chromium, copper, etc. This is called extrinsic loss. ಆಯ್ತಾ, ಇಷ್ಟೇನೆ. ಸೊ ಲಾಸ್ ಆಫ್ ಎನರ್ಜಿ ಡ್ಯೂ ಟು ಅಬ್ಸಾರ್ಪ್ಷನ್ ಬೈ ದ ಮೆಟೀರಿಯಲ್. ಯಾವ ಮೆಟೀರಿಯಲ್? ಐದರ್ ಕೋರ್ ಮೆಟೀರಿಯಲ್ ಆರ್ ಇಂಪ್ಯೂರಿಟೀಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದ ಮೆಟೀರಿಯಲ್. ಕೋರ್ ಇಂದ ಆದ್ರೆ ಇಂಟ್ರೆನ್ಸಿಕ್ ಅಂತಾರೆ, ಮತ್ತು ಇಂಪ್ಯೂರಿಟೀಸ್ ಇಂದ ಆದರೆ ಅದನ್ನು ಎಕ್ಸ್ಟ್ರೆನ್ಸಿಕ್ ಅಂತ ಕರೀತಾರೆ ಅಷ್ಟೇನೆ. ಸೊ ಯು ನೀಡ್ ನಾಟ್ ಹ್ಯಾವ್ ಟು ಎಕ್ಸ್ಪ್ಲೈನ್ ಹೌ ಟು ಮಿನಿಮೈಸ್ ದಿ ಅಬ್ಸಾರ್ಪ್ಷನ್ ಲಾಸ್. ಸೊ ದಟ್ ಈಸ್ ನಾಟ್ ರಿಕ್ವೈರ್ಡ್ ಇನ್ ಫ್ಯಾಕ್ಟ್ ಹಿಯರ್. Okay, now comes dispersive loss. The spreading of pulse energy due to variable refractive index is known as dispersion loss. As the light propagates through the optical fiber, it will spread due to variable refractive index. This is called dispersion, spreading loss. This loss occurs when light containing wide range of electromagnetic waves propagate through the optical fiber. Of course, we are sending our waves of different wavelength, different frequency. Therefore, there will be more loss. Right? This is dispersive loss. This is another loss. ಈ ತರ ಬ್ರೀಫ್ ಆಗಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ಕೊಂಡು ಹೋಗಿ. ಡೋಂಟ್ ಗೋ ಇನ್ ಡೀಟೇಲ್ ಅಬೌಟ್ ದ ಲಾಸ್ ಮೆಕ್ಯಾನಿಸಮ್. ಅದೇ ಏನಾದ್ರು ಅವರು ಪರ್ಟಿಕ್ಯುಲರ್ ಆಗಿ ಅಬ್ಸಾರ್ಪ್ಷನ್ ಲಾಸ್ ಅನ್ನ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿ ಡಿಸ್ಕಸ್ ಎನಿ 2 ಲಾಸ್ ಮೆಕ್ಯಾನಿಸಮ್ಸ್ ಅಂತ ಹೇಳಿ 8 ಮಾರ್ಕ್ಸ್ ಇಟ್ಟಿದ್ರೆ ಅವಾಗ ದೆನ್ ಫಾರ್ ಈಚ್ ಲಾಸ್ ಯು ಹ್ಯಾವ್ ಟು ಗಿವ್ ಮೋರ್ ಇಂಪಾರ್ಟೆನ್ಸ್, 4 marks. First, what is that loss, where it occurs, what is the reason for that, how to minimize, like this you have to elaborate. Okay, now next point is scattering loss. Scattering loss, the light undergoes scattering due to imperfection and impurity present and hence the loss of energy. So scattering is mainly due to imperfections and defects. Imperfections ಅಂದ್ರೆ ಡಿಫೆಕ್ಟ್ಸ್. ನೋಡಿ, ನೀವು ಈ ತರ ಈ ವರ್ಡ್ ಅನ್ನು ಯೂಸ್ ಮಾಡಬಹುದು. ಇಲ್ಲಿ ನಾನು ಕೊಟ್ಟಿರೋ ವರ್ಡ್ ಅನ್ನೇ ಉಪಯೋಗಿಸಬೇಕಂತ ಏನಿಲ್ಲ. ದ ಲೈಟ್ ಸ್ಕ್ಯಾಟರಿಂಗ್ ಡ್ಯೂ ಟು defects present in the optical fiber and impurities present in the optical fiber is known as scattering loss. ನಿಮ್ಮ ಓನ್ ವರ್ಡ್ಸ್ ಅಲ್ಲಿ ಬರ್ದ್ಬಿಡ್ರಿ. ನೋಡಿ, ಮೀನಿಂಗ್ ಗೊತ್ತಾಗ್ಬಿಟ್ರೆ ನಿಮಗೆ ಗೊತ್ತಿರೋ ಸಿಂಪಲ್ ವರ್ಡ್ಸ್ ಅನ್ನೇ ಉಪಯೋಗಿಸ್ಕೊಳ್ಳಿ. ದ ಲಾಸ್ ಆಫ್ ಎನರ್ಜಿ ಡ್ಯೂ ಟು ಸ್ಕ್ಯಾಟರಿಂಗ್ ಈಸ್ ನೋನ್ ಆಸ್ ಸ್ಕ್ಯಾಟರಿಂಗ್ ಲಾಸ್. Scattering occurs mainly because of defects present in the optical fiber and impurities present in the optical fiber. That's all, right? ಬೇಕು ಅಂತಂದ್ರೆ ಸ್ಕ್ಯಾಟ್ರಿಂಗ್ ಅಲ್ಲಿ ಎರಡು ತರ ಇದೆ, ರ್ಯಾಲೆ ಸ್ಕ್ಯಾಟ್ರಿಂಗ್ ಮತ್ತೆ ಮೀಸ್ ಸ್ಕ್ಯಾಟ್ರಿಂಗ್ ಅಂತ ಒಂದು ಲೈನ್ ಅನ್ನ ಮೆನ್ಷನ್ ಮಾಡಿ ಅಷ್ಟೇನೆ. ವಾಟ್ ಈಸ್ ರ್ಯಾಲೆ ಸ್ಕ್ಯಾಟ್ರಿಂಗ್, ವಾಟ್ ಈಸ್ ಮೀಸ್ ಸ್ಕ್ಯಾಟ್ರಿಂಗ್, ಯು ನೀಡ್ ನಾಟ್ ಹ್ಯಾವ್ ಟು ಎಲಾಬ್ರೇಟ್ ಬಿಕಾಸ್ question is very limited, the marks are very limited. You have to explain, mention 4 different classes. ಅಲ್ಲಿ ಅವರು ಮೆನ್ಷನ್ ಅಂತ ಹೇಳಿಲ್ಲ. ಸಪೋಸ್ ಮೆನ್ಷನ್ ಅಂತ ಹೇಳ್ಬಿಟ್ಟಿದ್ರೆ ಜಸ್ಟ್ ಯು ಮೆನ್ಷನ್ ಅಬ್ಸಾರ್ಪ್ಷನ್, ಡಿಸ್ಪರ್ಷನ್, ಸ್ಕ್ಯಾಟರಿಂಗ್ ಅಂಡ್ ಬೆಂಡಿಂಗ್ ಅಂತ ಹೇಳ್ಬೋದಾಗಿತ್ತು. ಎಕ್ಸ್ಪ್ಲೈನ್ ಅಂತ ಕೇಳಿರೋದ್ರಿಂದ ಬ್ರೀಫ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಯು ಹ್ಯಾವ್ ಟು ಗಿವ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಈಸ್ ಬೆಂಡಿಂಗ್ ಲಾಸ್, ಆಲ್ಸೋ ಕಾಲ್ಡ್ ಆಸ್ ರೇಡಿಯೇಷನ್ ಲಾಸ್ ಅಥವಾ ಜೆಮೆಟ್ರಿಕಲ್ ಲಾಸ್. ಈ ಆಪ್ಟಿಕಲ್ ಫೈಬರ್ಸ್ ಅನ್ನು ಜಾಸ್ತಿ ಬೆಂಡ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಬೆಂಡ್ ಮಾಡಿಬಿಟ್ರೆ ಏನಾಗುತ್ತೆ, ಟೋಟಲ್ ಇಂಟರ್ನಲ್ ರಿಫ್ಲೆಕ್ಷನ್ ಆಗೋದಿಲ್ಲ. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಲೈಟ್ ಬೇರೆ ಕಡೆ ಎಲ್ಲೋ ಎಸ್ಕೇಪ್ ಆಗುತ್ತೆ. ದಿಸ್ ಈಸ್ ಕಾಲ್ಡ್ ಬೆಂಡಿಂಗ್ ಲಾಸ್. ಅಷ್ಟೇನೆ, ಮುಗಿದೋಯ್ತು. ಇದನ್ನು ನಿಮ್ಮ ಓನ್ ವರ್ಡ್ಸ್ ಅಲ್ಲಿ ಬರೀರಿ, ಅಲ್ಲಿ ಕೊಟ್ಟಿರೋ ಆನ್ಸರ್ ನೋಡೋಕೆ ಹೋಗಬೇಡಿ. ವೆನ್ ಆಪ್ಟಿಕಲ್ ಫೈಬರ್ ಇಸ್ ಬೆಂಡ್ ಬಿಯಾಂಡ್ ದ ಲಿಮಿಟ್, ಯಾವುದೋ ಒಂದು ಲಿಮಿಟ್ ಇರುತ್ತೆ, ಅದಕ್ಕಿಂತ ಹೆಚ್ಚಿನದಾಗಿ ಬೆಂಡ್ ಮಾಡಿದ್ರೆ, ಇಫ್ ದ ಆಪ್ಟಿಕಲ್ ಫೈಬರ್ ಇಸ್ ಬೆಂಡ್ ಬಿಯಾಂಡ್ ದ ಲಿಮಿಟ್, ದೆನ್ ಲೈಟ್ ಡು ನಾಟ್ ಅಂಡರ್ಗೋ ಟೋಟಲ್ ಇಂಟರ್ನಲ್ ರಿಫ್ಲೆಕ್ಷನ್ and hence energy is lost. This is known as bending loss. ಮುಗೀತಷ್ಟೇನೆ. ಸೊ ಅಬ್ಸಾರ್ಪ್ಷನ್ ಲಾಸ್, ಲೈಟ್ ಅಬ್ಸಾರ್ಬ್ ಆಗೋದ್ರಿಂದ. ಹೂ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಅಬ್ಸಾರ್ಬ್? ಮೆಟೀರಿಯಲ್ ಇಟ್ ಸೆಲ್ಫ್, ಕೋರ್ ಮೆಟೀರಿಯಲ್ ಇಟ್ ಸೆಲ್ಫ್ ಆರ್ ಸಮ್ ಇಂಪ್ಯೂರಿಟೀಸ್. ಕೋರ್ ಮೆಟೀರಿಯಲ್ ಇಂದ ಬರೋದು ಇಂಟ್ರೆನ್ಸಿಕ್ ಲಾಸ್, ಇಂಪ್ಯೂರಿಟೀಸ್ ಇಂದ ಬರೋದು ಎಕ್ಸ್ಟೆನ್ಸಿಕ್ ಲಾಸ್. ಡಿಸ್ಪರ್ಷನ್, when light is propagating in optical fiber it will spread due to variable refractive index. Next, scattering. If there are any defects in the material, if there are any impurities in the optical fiber, light undergoes scattering. This is also a loss. Bending. If there is too much of bending of the fiber, there will be no total internal reflection. Hence, there is loss. Like this, you have to explain. Okay. Well, this is about question number 1B. Well, next comes the numerical problem. Given numerical aperture is 0.30, refractive index of core is 1.49. Calculate the critical angle for core cladding interface. Well, I will solve this numerical problem. It is like this. Numerical aperture n1, actually it should be small n1. It is not capital N1, it is small n1. Now numerical aperture formula, you know, it is equal to root of n1 square minus n2 square. Square on both the sides. Numerical aperture whole square is equal to n1 square minus n2 square. Please find out n2 square now. It is n1 square minus numerical aperture square. That is n1 is 1.49 square minus 0.3 square. Well, n2 square comes out to be, just I will do it for you, 1.49 square minus 0.3 square is 2.13. Please, you can try simultaneously. Root of this is 1.46. So n2 is 1.46. I have n2 and n1. Well, in the optical fiber, look at the diagram. This is core, right? And this is clad. Diagram is not so proper. This is clad, right? So clad, this is clad, and afterwards I have what is called skin. Okay. Well, this point light, and this is the axis of the optical fiber. So I will change the color of the pen. Now a ray of light is traveling here. This is the point where I have to draw the normal, and then total internal reflection takes place. This region is clad, having refractive index n2, and this angle is theta. Theta is equal to 90 degree. Okay, and this region is core, having refractive index n1. This angle is theta c. Well, now I shall apply Snell's law here. That is n1 sin theta c is equal to n2 sin theta. So sin theta c is equal to n2 into sin 90, because the angle is, ray is grazing, divided by n1. Simplify. Sin theta c is equal to n2 is already there, 1.46. Sin 90 is 1, divided by n1 is 1.49. That is 1.46 divided by 1.49, 0.979. So this is 0.979. I want theta c, that is sin inverse of 0.979. So sin inverse of this is 78.48 degree. So angle of critical angle is 78.48 degree. Well, here is the answer. Well, 78.23, I just considered all the possible decimals. I got 78.48 degree. So this is the answer for this question. Dear students, I hope you are following. So this itself took nearly 20 minutes. I think it is better to stop here. But in subsequent videos I will try to cover all the all the questions in that particular module. ಅಂದ್ರೆ ಈಗ ಈ ಮಾಡ್ಯೂಲ್ ಅಲ್ಲಿ ನಾನು ಟೋಟಲಿ 2 ಕ್ವೆಶ್ಚನ್ಸ್ ಅನ್ನು ಕವರ್ ಮಾಡಬೇಕಾಗಿತ್ತು. I took little bit more time for explaining the question paper pattern, so therefore I could not. If I take up the next question, the video duration becomes lengthy, so I don't want you to get bored, so I stop here. Immediately I will come with the next video on this particular module, and also in the subsequent videos we will discuss all the questions in detail. Please share your comments and give me suggestions so that I will improvise this presentation. Okay, thank you. Like my videos. Thank you very much.